Although a number of architects are starting to provide building information models, cost estimators are often required to perform takeoffs based on 2D design data or high-quality digital images from the design. For this reason, Autodesk Quantity Takeoff has a full set of intuitive manual takeoff tools, enabling you to perform on-screen takeoff of design data such as walls, doors, and windows. Even when there is no intelligence behind the files being used, that is, 2D files and images containing lines and arcs with no concept of scale or the objects they represent, with Autodesk Quantity Takeoff, or QTO, you can manually measure an object of known dimensions and use this to set the scale of the project files. All linear and area takeoffs are then automatically calculated and recorded in the correct scale. Let's focus on some of the manual takeoff tools available to you. When quantifying the number of doors on a project, for example, you need a means of marking each door as you count them. If you had all of your sheets printed out, then you'd likely be using different colored pens and symbols to classify each door type and keep track of the count as you work through the sheets. Autodesk QTO offers the same takeoff method in a digital format, allowing you to quickly count and track items within the sheet. Again, colors and symbols can be chosen for each object type, and these are automatically tracked, so each count on the sheet directly corresponds to an item in the takeoff palette. These can easily be grouped and organized exactly how you want them. And any mistakes can be quickly rectified by dragging and dropping an item from one group into another, with Autodesk QTO reassigning the relevant takeoff symbol. When quantifying walls, for example, tools are available for you to perform linear takeoffs with a single click. Although these 2D sheets have no object intelligence, Autodesk QTO can recognize individual lines. And as we set up the scale earlier, merely clicking on a line representing a wall provides you with an accurate length. The takeoff group can be renamed to identify the object type, and if required, additional properties can be assigned, including details of the object's construction. For example, you may wish to calculate the number of studs and gypsum boards required for each section of wall, and the total number for the project, all of which can be easily calculated from the takeoff. When taking off areas such as flooring, Autodesk QTO provides tools to quickly mark out and calculate the area. This is particularly efficient when quantifying the area of non-uniform spaces, such as open-plan office areas and corridors. Again, colors can be used to identify different areas along with standard hatch patterns. While carrying out the quantification, the workbook is also being built out, providing another view of the building components. The workbook allows you to add initial cost information against each takeoff group, including material and labor costs or flat fee subcontractor costs as and when they're available. Reports can be generated directly from Autodesk QTO, and quantities can be exported to Microsoft Excel. With the availability of a building information model, Autodesk Quantity Takeoff, or QTO, enables you to spend less time counting and measuring and more time focusing on creating your estimate. In this example, we'll start by using a uniformat catalog to organize the takeoff. We'll also use a DWF file exported directly from the design intent model. A DWF file exported from Revit can not only contain the 3D model, but also the associated 2D sheets. Due to the intelligence inherent in the model through BIM, QTO can automatically search through this information and take off the entire model at the click of a button. Furthermore, as the 2D sheets are associated with the model, Autodesk QTO cross-references these for all taken-off items. The power of this is seen when reviewing the takeoff palette, as each item may be presented in a number of views, that is, the model view and each 2D sheet that contains the selected item. An incredibly easy-to-use drag-and-drop interface enables you to move the takeoff items into the catalog structure you're using. And all the while, the workbook continues to build up with information. For example, looking at these 4 7/8" partition walls, while the model takeoff identified and recorded each instance of this wall type, Autodesk QTO is also accumulating and presenting you with the total footage, something that would traditionally have taken hours or days to calculate, along with removing the risk of human error. All of this is possible due to modeling building components that know what they are, not simply a solid object that represents a wall, for example, but an element that knows it's a wall, knows its dimensions, and how it's constructed, and so on. This is the power of BIM and how it takes Autodesk QTO to the next level. But it doesn't end there. Autodesk has partnered with a number of estimating solutions, such as Sage Timberline, MC2, and RIB, whose integration with Autodesk QTO enable you to export your takeoff into those estimating packages. Let's take a closer look at the Autodesk QTO to Sage Timberline office estimating workflow as an example. When integrating with Sage Timberline office estimating, Autodesk QTO enables you to import a catalog of items and assemblies. You can then associate elements from the model with the items and assemblies. Once the associations are made, it's a matter of one click to export the quantities and dimensions from Autodesk QTO and create a new estimate in Sage Timberline Office Estimating. So let's start with the same Trapilo design intent.dwf file. Though rather than using the Uniformat catalog, we'll import a catalog from Sage Timberline Office Estimating. The integration plugin provides access to an existing estimate file, a .pee, if you use template estimate files, for example, or the entire database, pei.dat, from anywhere on the machine or network. Having made your selection, you have the ability to filter your selection of assemblies and items. So when importing a database, as in this example, you have control over which items and assemblies you wish to include. Autodesk QTO remembers your selection and applies the same level of filtering the next time you open this database, saving you from repeating this operation each time. As with Uniformat, the catalog is available from within the Takeoff palette, and the model structure is seen in the Model palette. You can select a group of elements in the model and hide everything else to make it easier to see what you're taking off. Using the Takeoff to Item option, you can map the element type directly to a specific item or assembly within the catalog. Autodesk QTO then takes that item off and assigns all 278 instances of the wall, in this example, directly to the corresponding catalog item. This provides a more methodical workflow as opposed to the one-click model takeoff and subsequent drag-and-drop catalog restructuring. Having assigned the wall type to an assembly, you can then define how Autodesk QTO should quantify that item, whether it should be a count or quantified by volume, area, or in this case, linear. You're also presented with additional catalog parameters, values that are required to create an accurate estimate. These default variables and units auto-populate based upon the selected assembly, and you need to map these variables to the quantities or attributes from the wall object type in this example. A formula editor is available to either select the relevant attribute or property, such as length or height. Alternatively, if an attribute doesn't exist, the formula editor allows you to calculate a value from other known attributes. Now that these variables are mapped to the relevant model attributes, when you look at the properties for each wall, you can see the quantities associated with each dimension. For example, the linked length and height. When this wall is generated in the estimate, these are the values that will be quantified in the assembly. These quantities can be exported to Sage Timberline Office Estimating. This is not an export-import integration. When you export from Autodesk QTO, it actually performs the takeoff and creates an estimate which can be opened and reviewed within Sage Timberline Office Estimating. The best way to review the estimate created by Autodesk QTO is to use the Review Assemblies mode within Sage Timberline Office Estimating. You can see how each wall within the model has created a pass in the assembly takeoff, and further the specific quantities that populated the variable entries. As you click through the different passes, you can see the length and height of each wall are populated with the specific quantities from the model. Therefore, by using Autodesk's Revit platform for BIM, object quantities, doors, windows, walls, etc., and dimensions are stored within the model. which can be extracted using Autodesk QTO for use within Sage Timberline Office Estimating. Simply drag and drop the model elements to the estimating database for a simple one-time integration setup. Once this mapping is completed, it's stored within Autodesk QTO for use on subsequent projects. Exporting this data to estimating provides a fast, accurate, and automated process for creating cost estimates.